Thank you so much for coming to this session. This is a 2-hour talk, 2-hour discussion, and the idea is that, as the title of the program says, XR research programs, Wallonia, the region in Belgium, meets UK and Morocco. We have quite a few participants, so this discussion is going to be divided into multiple parts. I'll be inviting different participants to present their part in the first hour. We're going to start with the Belgian participants, then move on to the participants from Morocco to present their research. And that's going to be followed by our colleagues from the UK, from Royal College of Art. And then the second hour, we're going to spend discussing different research topics and also industrial use cases related to XR applications, how the academic knowledge is transferred to the industry in different countries, all the different research topics that we are working on, starting from intelligent mobility to human-robot collaboration, to very technical topics, how we can design, like the 3D models for all the objects that we use and that appear in XR applications. As you can see, there's 9 participants, actually 8 participants, 8 speakers today. One was not able to come, unfortunately. So after I will remind you about that, but in the second hour, I would be very happy to hear some questions from the audience as well. So do not hesitate after, if you decide to stay, to ask questions to our speakers so we can have an even more interesting discussion. Right, so as I said, in short, these are the objectives for today's session. To hear more about the different XR research programs in Belgium, Morocco, and the UK, we'll see some examples of how the scientific knowledge conducted at the universities in 3 countries is then transferred to the real-world industrial applications. And that's going to be followed by a discussion about XR applications, challenges, future of XR in both research and industry. I really hope that this is going to be interesting to you. So buckle up for the first hour of presentations. Each group of speakers is going to have more or less 20 minutes to present. And then obviously you will be able to ask questions, and hopefully the discussion is going to be very interesting afterwards as well. I will not be on the stage the whole time because I'll be moderating this panel. I won't be presenting anything. So I would like to invite the first group of speakers, Thierry Dutoit, Daniele Bonato, Rayana, are we on the good? Yeah. Alani, thank you, and Kevin Eladad. Thank you so much. I see that the slides are not up to date, unfortunately, because your names and photos were supposed to appear, but that's not a big problem, I guess. So I will let you then present the big project that we call Val4XR. Val4XR is an inter-university research project in Wallonia. All the French-speaking universities in Belgium are involved. So there is 10 PhD students and 4 postdoc researchers that work on this project. University of Mons, University of Liège, Université Libre de Bruxelles, Université Catholique de Louvain, and Namur, Université de Namur. They all work on this big inter-university research project aiming at conducting scientific research in XR topics with the idea of collaborating directly with the companies, with the industry in Wallonia to discover the real use cases that Wallonia needs to modernize, automate, and become more competitive in terms of what we do in Wallonia and in Belgium, aiming at developing a so-called Industry 5.0. So I will let the speakers now present their parts. We will start with the work package 1, which we call Tech for XR. So all the technical components, all the building blocks, all the technological bricks that are necessary for XR to function in general, but also specifically related to perception and interaction. Yes.
Hey.
Thank you.
Can you hear me? Can you hear me? Yes, a bit. Okay. Hi, my name is Thierry Dutoit. I'm happy to be here. I'm leading this. What's that? Okay, yeah, okay, sure. I'm leading this lab at University of Mons, where we work on extended reality. My PhD students are the ones who are lying at the back of the room over there. Okay. So, as Luca mentioned, we have several work packages in this project, and I'm responsible for work package 1, in which we work on immersive 3D sound, interaction with smart virtual agents, collaborative immersive analytics, and visual attention for optimizing XR content. So the next 4 slides will be 1 slide per PhD, basically. You didn't mention that, but we have 10 PhDs that are running on right now on extended reality in Wallonia. Okay. First PhD, Alexandre, at the back of the room, is working on individualized head-related transfer functions for estimating user-tailored immersive experiences. The idea is that extended reality is not only about visuals, it's also about audio, and even audio is very important for the sense of presence. And when you hear something coming from the left, for instance, you hear it differently from your left and right ears, because mostly of the shape of your head and also the shape of your ears. And so if you want to simulate that in the virtual world, you have to come up with a means of inventing the so-called head-related transfer functions from the position of the objects to your head. And these things can be measured, basically. You can measure the head-related transfer functions, but it's very hard. I mean, it takes 1 hour. It's expensive. You have to have a complete setup with lots of loudspeakers and microphones, and putting microphones in the ears of the people. So it's not convenient at all. But it needs to be done very precisely, because if you use someone else's head-related transfer functions, then you don't have this feeling of presence. And for that, so the idea of the PhD is that we want to predict the head-related transfer functions from the shape of the ears of someone using consumer-grade quality pictures, basically. You take a snapshot of the head and of the ears. So that's the first PhD. Second PhD we have is Thomas Baldassar. He's working on expressive interactive agents. So the idea is, as many other people, we are working on, and I know that some people mentioned that to me just a few minutes ago, we're working on virtual expressive agents, basically. So non-playable characters, smart non-playable characters, basically. With many kinds of applications. One of the applications is shown here is you have an interaction between a real medical doctor and virtual patients to teach medical doctors how to interact with patients, basically. But it can be many other applications related to psychology, basically, many of them. So that's the second PhD we have. Third PhD on technology is Théo Leclerc and Thibaut Septon, also Maxime Cauze. I don't know if they're here. They said they would be here, but they're not. So they work mostly at, so that's the University of Namur. They work mostly on information clutter management. The idea is that when you are using extended realities, you are pushing information in front of your eyes from the real world, and there could be many kinds of things that can be shown. And if you show too much, then you just don't show anything, because people don't react to information clutter. So you have to select very carefully what you show, what and when you show things. And so this group works mostly on that. Maxime Cauze has finished his PhD. So most of the PhD that we will mention now are just starting right now. We have no results, most of them, except for Maxime. Maxime is from the University of Namur, finished his PhD already, but the others didn't, of course. They're also working on multimodal interaction techniques for mixed reality environments. So these are the PhDs from University of Namur. And we all work together, of course. I'm mentioning these universities, but these people work together, okay? And especially on proof of concept, but Kevin will talk about it later. Adrien is over there also. Adrien Kinard's PhD thesis is on environment adaptation depending on visual attention in 3D. So the idea is that if you want to learn something using virtual or extended reality, the things that you have to learn, I mean, the difficulty of the problem has to be adapted to your own capacity of solving the problem. And so, for instance, if you are playing a game, or if you are learning to play an instrument, a musical instrument, then the problem that is given to you needs to be solvable to you. And for that, typically, the complexity of the problem has to be adapted to your own performance. And for that, we use visual attention prediction. So I don't know if you can, well, you can see it from the screen over there. We adapt the environment in which the game is performed by extracting the scenes and extracting the eye tracking from the helmet at the same time. From the scene, we predict the 3D visual attention, and we compare it to the actual visual attention from the helmet, and from that we can analyze the cognitive load. We estimate the cognitive load from the experiment. So we try to adapt the complexity of the task to the real time to the performance of the player or the learner. And that's it. But that's for the first PhD thesis for work package 1. So I'll give the floor to Daniele for work package 2.
Do you hear me well? Perfect. So welcome, everyone. I'm Daniele Bonatto. I'm an assistant professor at the Free University of Brussels, here in Belgium. So it's not that far away. I don't work exactly in XR. I work on technologies that are under the XR. So I will speak a little bit more about it, but I really work on image processing. I have something like 6 PhDs that sadly weren't able to come because apparently they have too much work. That's my fault. So let's start with what we do. This one, I think. Yes. So my unit is the data for XR, and actually we are doing a lot of things. We focus on avatar synthesis, so how to recreate some heads, some bodies in 3D, how to capture them. We work on new 3D representations for view synthesis, like Gaussian splatting and NORF, but many other representations also. We work with UCL, which is another university in Belgium, on 3D pose estimation. And finally, we start working on generative AI. As you can see, for example, my profile picture was completely done by AI. So, what does it mean for us to work in this kind of project? The first thing that we want to do is to capture, for example, facial expressions. Because if you want some immersion in XR, in VR, you need to transmit what people are doing behind the headset, behind some cameras. So we try to capture the facial expression and transmit them to the other users. And to do that, we also focus our effort into MPEG standardizations. So we really work on the algorithms to allow us to compress avatar images and to transmit them through internet in real time. But then, suppose you have the face, you still don't have any environment for that face. So we built some very nice studios with a lot of cameras. I think my current one has 32 cameras, at least 4K cameras, but we have a little bit more exotic cameras, let's say. And we will capture some scene of the real world. And then we will show it on a 3D screen. You probably saw several 3D screens, at least one looking glass downstairs. And this is the kind of screen where we can show the avatar with the environment that we captured. Now that it's easy to say, OK, we have an acquisition room, we try to capture some scenes, but in reality, it means that we have a lot of issues. Like we need to synchronize cameras, we need to color correct everything, because if you have non-color corrected, so the colors are not coherent between the different pictures, you will not be able to generate some nice 3D synthesis of the space. And finally, we have a lot of problems with synchronization, because you can imagine with 32 cameras, it's very difficult to capture the data and store it. But that's not all. We also developed several other technologies, like we try to apply Gaussian splatting for SLAM applications, so to have a better 3D view of the street, to help autonomous cars, for example. We try to improve the video in Gaussian splatting, because at the moment the results are not that good. And working at the standardization, I saw a lot of results, and most of the time they are not perfect. We also work in other fields like segmentation of Gaussian splatting, because when you have this 3D point cloud, you want to segment it, to, for example, to increase editability. So you want to take the 3D model and move it in space. We work with several algorithms, so Gaussian splatting already said, but the last part of my lab is working on building the next generation of 3D screens. So we really build glass-free 3D screens, so screens where you can have like 10 people in front of them, and they all see a different point of view of the same scene in real time. Another line of research, as I was saying, is that, okay, we have avatar and we have 3D, we have the screens, but we need to animate everything. So one line of research is focused on estimating the pose of the avatars, to try to reconstruct the movement, to study. So for example, in medical application, it could be interesting to study what happened. You can monitor operators or an operation. And finally, I said we worked on generative AI, but we are just starting. One of the main purposes for us is that when you create novel views, so you see in the first video here, there was only one image, and we generated all the missing ones with algorithms. But you can see that as we had only one image, we have a lot of holes everywhere. So we need to use Gen AI, for example, to fill the holes and block the occlusions, or to insert 3D objects in the scene. That's all for me. Thank you very much.
So hello, everyone. My name is Rayana Alani. I'm actually an architect, so I'm here to talk about human and users, not really about technologies. So how to design inclusive, responsible, and sustainable XR experience, user experiences. So we've talked about technology bricks, data bricks, and here we want to talk how to translate all these technologies in a meaningful user experience, in a meaningful user experience, and orchestrate it to make sense, to make an experience make sense. So I think for the last 2 days we talked about user experience at the conference, and I think we witnessed a paradigm shift about user experience in 3 ways or 3 parts. The first part is about how XR should empower users, not replace them. It's about agency, how can expand the capabilities of users and not replace them or make them vulnerable. The second one is about the systemic way to design user experience. So as you can see here, it's a use case we worked on in the WAL for XR project. It's about a factory of a timber structure, frame, a prefabricated timber structure, and the manager asked us how to integrate AR to speed up the wood assembly in the workshop of the factory. As you can see, the icon in green. So we observed the task of the workers. We asked the workers. They were very happy and excited about the technology. So it's a good step, because often the the needs of the manager sometimes are divergent from the needs of the workers, so this time it was good. But then we zoomed out to look about all of the process, the ecosystem, the data flows, the workflows, and then we saw that the designers who deliver the assembly plans worked with software tools which not really adapted to deliver information to be displayed with AR technology. So here we realized that we have to think about user experience in a more systemic way and sometimes zoom in but also zoom out to look about the whole process. So also the third part of this paradigm shift is about the traditional user experience, which is have always been two-dimensional, flat screens, clicking, scrolling, but now the interaction became more spatial, became more embodied interaction, so the users live the experience, not only use the technology. So this is the three parts of this paradigm shift about user experience, and we need new metrics to measure the quality of user experience, and this is what the first PhD student in this work package work on is about developing or specifying new metrics to evaluate the quality of user experience. As you can see here in the cloud, the work cloud, it's a literature review about the dimensions of user experience in virtual reality, but also it can be, it's not static, it can balance, the dimension can balance also from augmented reality to virtual reality or mixed reality. So let me talk about one concept, which is also important in user experience. It's about engagement, and this is to what lead us to the second PhD here in this work package. So engagement is about capturing attention and the motivation of the user to fulfill a task. I think we already saw this in the attention economy about social media. So for the XR experience, we use some mechanism like gamification to capture the attention and make people, users, more engaged to fulfill their task using XR. But also, we have to make sure that the XR experience doesn't push the users to their healthy limits. So we have to make sure that people that we can expand and augment the capabilities of the users and not make them vulnerable with this mechanism of gamification. Those are the second PhD. And we talked also about agency, about capabilities, but this is not only about interaction, but also about the control and the privacy of our data. So the interaction is about how can we use the system, the technology, and privacy, cybersecurity, how the system can interpret our profiles, our data, our behaviors. So in XR, we can collect too many data about biometric data, behavioral data, but also the environment data. And for this third PhD work, we focus on how privacy becomes a part of the user experience from the first stage of the design process, for also the autonomy and the right to sometimes refuse or not permit data collection and not break in the experience. It has not to be a condition to have a personalized, a good experience, but also the users have the right to to refuse to the data collection. So this is about the work package about user experience, and I leave the floor to Kevin to speak about the proof of concepts.
So, hi everyone, I'm Kevin. I am the project management officer for Wal4XR. How do you do to move to the next slide? Like that, perfect. So I'm the guy that's supposed to shout on these guys if they don't do their job, which I do not do because they're all bigger than me. So As you noticed, all the work we presented here is research oriented towards building the building blocks of what is to become an XR application at the end, right? And there's a reason for that. One of the primary objectives of the WAL4XR project, and one of the objectives of the Wallonian region, is to boost the activity of extended reality in the region, right? So to do that, we want to be able to transfer the technology that is being developed in science, in research, towards the industry, right? Without a specific one target, single target. So in order to do that, we defined 4 main proof of concepts to be developed based on the technology and other stuff that are being developed by our researchers and our PhD students, right? That's why all the subjects are oriented towards the building blocks of XR applications. Here you can see the 4 main, the 4 ones that we are currently focused on, which is focus on, if you look at the top right, building applications where XR is to be used to help people in the construction business. The second one is XR for learning. As the name suggests, here we try to use immersive experiences, human agent interactions, and technologies like that to improve the way tutoring, training is made, whether it's in the industry or in a classroom, right? On the bottom right, so the name is XR for production, but the idea is focusing on design and on prototyping, basically. So we're talking about co-presence in an immersive world, exchange of virtual asset, transfer from real asset to virtual asset, so that people can more easily, even if they're not in the same room, exchange ideas, prototype, discuss, think, right? To design something they want to produce at the end. And the last one is XR for maintenance. As you can see here, the goal is to be able to provide tools in order to improve the task of maintaining machines in the industry, right? And the product of all this, what we want to do at the end of the project, is to provide as many resources as possible that are as relevant as possible to the industry and to the society, basically, so that it's easier for them to build upon them and create new applications and provide value, right? So here you have a video produced by the Mill, one of our partners. Of course, we're not very advanced, like Professor Dutoit said, but we have at least some of the things we can show, some demos we can show. I'm not sure how to play it. But here you're going to see an assembly task with the instructions that you need to follow. It's not very clear, but in a VR headset it's a lot clearer. You can see what you're supposed to put and where, and in AR, sorry. And then you can put and do the assembly task without having to follow a complicated manual, which is most of the time written in a language that's not your native language, right? Yeah, so you got the idea. And I invite you to go check out our booth that we have set up downstairs, where you'll see a lot of our partners, depending on who's there at that time. But I cannot assure you who's going to be there, but I can assure you it will be an interesting discussion if you go. So I invite you wholeheartedly to join, right? Luca?
Thanks a lot. That was really interesting. Now I would like to invite the 2 speakers from EMSI Morocco, the engineering school from Morocco, Yassine and Soufiane, to talk about SafeOps XR, the immersive remote maintenance and robotic teleoperation research projects. So the floor is yours.
Hello, everyone. I'm very happy to be here. This is the big event in United XR Belgium. My name is Yassine Benouader. I'm HITT for XR Center at Laboratory Moroccan School of Engineering in Casablanca. I'm a gamer developer and generator of the film by AI and image, and XR mentoring some program in Africa and Europe and USA. And me, with this presentation, we present SafeOps with my colleague Soufiane Amour, is HITT for Robotics Center, is in the same laboratory. And today we present SafeOps is platform for remote maintenance and robotics. Okay. Yes. And industry is the big phase for industry, big phase for the remote maintenance and the robotics, and we have a lot of problem with how there's the access to some environments in industry, and we have, for example, first question, how we can enable safe, precise, and human-centered remote maintenance and robotic assistant operation in XR and AI. And now we talk with focus for four problem of hazardous environment to explore the worker or the operator to access the dangerous environment. And we have second, travel costs and delay. For example, who need to move physically expert in the same place. And we have precision and limitation with traditional remote and limited situation awareness. For example, use case here, for example, SafeOps XR, to get operator, you can get access from a distance and control the arm of robots. We have some robots there. For an arm of robots, we have some camera, and thus you can operator see you can see the operator, the real time, the use case, for example, remote assistant, for example, use case here, some electrical armor. And for example, we have on top of that AI assistant, you can, for example, get the operator and detect error and reduce mistakes for the person. And for example, real world scenario, you have some example industry scenario for chemical progression, high temperature foundries, electrical control panels. And all these use cases, you can, this SafeOps XR, you can reduce all the problem, get access with the robots or any environment. For example, in chemical progression, you can do the assistant. For example, you can operator get use case at distance. And for high temperature foundries, you can go the robots and the place for foundries. For example, electrical control panel, we have some use case can show you with Soufiane how you can robots get control with arm electrical, with get access to any person. And for extended remote observation, you have, for example, in a prior awareness, remote operator can real-time high-fidelity visual and sensor feedback from the remote environment. And we have digital overlay, for example, of get information in real time, and risk mitigation is important to eliminate the need for physical presence and dangerous zone. And we see the next robot platform with Soufiane is very professional for this use case. He's HITT for XR robot in laboratory. And Soufiane is your floor.
So, hello everyone. My name is Soufiane Amer, third year PhD student at EMSI Casablanca and also University of Hassan II in Morocco, and also head center of robotic field in our school. So first of all, before starting, I need to explain what is the difference between a cobot and a robot. So generally, a cobot is an abbreviation of collaborative robots. So the difference is that the cobot can work safely with the human. So it can be a cooperation, a collaboration, or a synchronization, depending on the use case. So we have many brands of cobots. The most famous one is UR5. I saw that in one of the exhibitors. So it's an European brand. There's many types. There's UR5, 10, 30, depending on the range and the payload. There's also Dozen, there's Kuka, ABB, and many other brands. For our laboratory, we have a Chinese brand called UFactory that we're going to see after. So the main core of our project, we have, first of all, we are giving an expert VR guidance. So we are providing a real-time immersive guidance to the site. Like, for example, helping the technicians via an augmented reality overlay, a teleoperation for our collaborative robot in risky environments or hazardous environments. And also we enhance safety by removing personnel from dangerous operation safety significantly when reducing risk of chemical processing and also high temperature. And of course, operational impacts. For example, we can improve the precision when using robots, especially in complex tasks with the use of XR and eliminating the need of experts for traveling. Experts can work directly from the teleoperation. And of course, the rapid response capability. So the system architecture, we have the XR layout worked by my colleague Yassine. So we have real-time feedback, a 3D visualization, and a hand tracking. And also the layout of AI and deep learning. For this moment, we only made the computer vision, for example, detecting the parts in our electric armor. We have the robotic control done by me, like, for example, the programming using Python, safety filters, and to avoid collusion. And the communication between our robots and the MetaQuest headsets. And of course, we need a backend and a cloud, for example, to make our API server and remote, and also the dashboard. So for our results, we first started by doing an XR view simulation. That was to make sure that everything works well. Also for our high fidelity simulation for remote industrial environments. And we did a real-time test and also visual feeds for our digital overlays, and an enhanced situation for awareness and prices control. And the cobot manipulation that I'm going to show next in our video, that we did the teleoperation. Actually, we used a U factory, not an ABB. And also, we did a maintenance use case using our MetaQuest headset. So here's the video. I don't know how to play it. How can I play? Just press. So this is a soap machine that we have in our school in EMSI. So it is divided to 3 parts. Here's the extruder when we have the raw material. And also this part that coats soap. This is an example of an electrical armor. So this is the U factory cobot that we've made. So it's connected to a camera and a mobile parts. So here I tried to make an example for example, shutting down one of the detectors using the cobot. So now we go into the remote parts, teleoperation, so done by Yassine. So he can control it from his desktop. As you can see, here's an HRC example, for example, giving me one of the tools. So that's it. Thank you for your attention.
Thank you very much. I would like to invite our two last speakers from the Royal College of Art, Professors Cyril Deals and Alia Sadipur, to come on the stage.
With the green one? Oh, it's going backward. Oh, that's me. Good afternoon, everyone. Thanks for making it. I'm trying to be short and concise. I think we are almost covered by all the amazing speakers today. My name is Ali. I'm from London, Royal College of Art. I'm directing the Computer Science Research Center. I think this is an image of where we are. So we have 3 campuses in London. We are from Battersea. I think Cyril and I actually having centers in that big cube-shaped building. And we have 4 Center of Excellences at the RCA, which Cyril actually will introduce: intelligent mobility, material science, Helen Hamlin, and computer science. So when I joined from Warwick to RCA, the mission was connecting STEM subjects to art and design. So I created a group that can actually work on the intelligent, immersive, and interactive technologies. And at the core, actually, they have information systems for collecting, warehousing, analysis, and visualization. I'm also patent holder for the least discovered senses like smell and taste for a system called Visual Flavor. All together with delivering like a multi-sensory kind of experiences, and it is all AI enabled and AI powered. This is my amazing team. I have affiliations with 4 other countries and universities, amazing universities. I also have very good friends here from Cyprus, which thank you very much to be here. So I had postdocs, PhDs mainly in my team, and we are keep adding and keep graduating from our center. So my previous last 2 kind of PhDs are one in Midjourney now, one in MIT, and it's a brilliant team. So what we're trying to do is actually creating believable, intuitive, and safe. What means intuitive is actually, so it's something like ChatGPT is not a new science, but the way that you're interacting with the LLM is actually changing everybody's life. So it's became quite simplified. Everybody can actually write, everybody can talk. So it's going back to the human basic senses of communication. And that makes it quite kind of useful. What means safe is actually, you want to actually rehearsing things in a safe environment that doesn't creating any post-traumatic kind of experiences. You don't want to actually put anyone's life in danger if you're a Formula 1 driver, if you're a firefighter, or different kind of categories. So that's why you need to have it safe. Unbelievable is actually suspending disbelief or uncanny valley or any other kind of terminology used. As everybody else in the speakers actually explained, so you're talking about creating immersive environments. It can be called digital twin, it can be called virtual world, it can be called anything. You're also thinking about objects in those environments. It can be like a human-machine interaction, it can be like scenarios like smart vehicles or smart kind of mobility or structures for like architecture or construction companies. And then at the same time, because we're talking about saving Earth and climate change and addressing all of these stuff, there's a lot of thing around optimization of the AI algorithm, making sure that it doesn't need actually hundreds of GPUs and hundreds of machines and energy and things like that, which is more like a marketing campaign for selling more GPUs and selling more energy in the future. These are the 4 areas that I want to actually focus for the next 5 years. We have partners in each area, but mainly is actually construction, disaster resilience, healthcare and well-being, and edutainment, which is education and entertainment. And these are actually, this is one of my favorite projects for the last year, which is a collaboration with the University of New South Wales in Sydney and the Foster and Partner, which is a big architecture kind of firm. And you can actually create digital twin of for decision making, for putting first responders for training, for putting citizens to have different experiences of like natural disasters and at different levels, so earth level, city level, or the street level. One of the main countries that I like, and I've been in Japan this year, was they are the best example of natural disaster. Anything you can imagine, it happens in Japan. So, and you can see actually, when we talk, for example, for autonomous driving, that road is no Tesla or no other kind of intelligent smart vehicle can use that road. So it's a lot about addressing these sort of issues in a safe environment, which we call a digital twin these days. So the project actually was funded by the EPSRC and one of the biggest virtual production network in the UK. Amazing experience because we cut out of nowhere and we had an immediate use case for making like a Godzilla movie with a virtual production team, which we didn't think about. But this is the end result. So this is technically when you're using like a scientific software like ANSYS, and then you're tweaking Unreal Physics engine to make sure that everything simulated is AI powered and is matching the identical kind of example. Sound? No sound? No sound. Oops. No video. Multi-sensory experience. Yeah. So we just tell the machine that these are the components of this building, designed by an architecture company, bricks, concrete, glass, whatever, and it creates actually its physics destruction behavior in Unreal. And you do this using AI for like 100 different kind of episodes to matching the identical real world example, how it actually ruined. And one of the use cases, as I mentioned, is definitely disaster, kind of addressing disaster kind of scenarios. But the other one, which we found it as a eureka moment, was like someone in Japan asked us if we can create the next Godzilla movie. So we can bring the whole city down with one machine, one GPU in one day. So we don't need like Warner Brothers or Netflix, the new owner, to do it. Okay. Moving on, so this is actually the facilities in the University of New South Wales. They are an amazing kind of team in creating like a 3D version of the Spark, a famous scientific kind of platform for wildfire. And they are quite advanced in the wildfire and issues around that. We worked with Hong Kong, the previous delegation in this room. So I had 2 projects and Cyril had one. And one of them was about addressing the back pain, creating an in-house kind of electronic to just monitoring kind of different body anatomies, because as a human, we have different anatomies and different shapes. So there's no one Fitbit or one Apple Watch that can address everything. We also had another interesting one, which is actually using the intuitive way of a human interaction with the machine. So you're telling the machine that I want a space with these assets inside it and I want to use it as a pharmacy. And the machine can actually generate you a 3D space with those assets you want to buy from IKEA or Vitro or whatever. At the same time, it can actually reading like the NICE guideline in the UK to make sure that the distance between the shelves are 1 point something that the wheelchair user can use it, so they can auditing the space as well. And it give you like a recommender machine, like your Netflix movie watching kind of recommender system options that as a human you can select which one you like more. And then you can actually immersing humans and machines inside that the space to see if they can reach to the performance actually designed for that specific task. So you can, at the end of the day, you can select. We work with an amazing company in the UK, a lovely lady who's a graduate of RCA, and she's actually working with most of the big brands, with like Roblox and MetaHuman and everybody, to creating like a virtual apparel for like the avatars and for different applications, from fashion to Snapchat to everything. In architecture, we had an amazing collaboration with the School of Architecture at the RCA to creating a method, a pipeline for computer vision and ML to detecting different dwellings and facades of the building and energy rating and things like that, just using like the Google panoramic images available everywhere. My amazing PhD students, there are award winners everywhere, and they got actually Red Dot, Ars Electronica, Lumen Prize multiple times, and most of the other conferences actually they got actually awards for the best papers and other things. One will present next week in Hong Kong, SIGGRAPH Asia with MIT, a paper for the SIGGRAPH art. One of the examples from my PhD student is this one. So it's a patented system called Delta E. It is an AI-powered kind of algorithm that can compensate the harmful energy of the blue light out of RGB of any display. And the blue light is actually the main reason for a sleeping disorder, eye fatigue, dry eye, many of the. So we managed with this system to increase the 20-minute safe use of VR headsets to 1.5 hours. And he has received amazing offers from Apple and HTC and some other companies to buy the technology. I did my PhD in use of actually systems for training medical students, XR AI-enabled system at the time. We had a virtual driving experience platform at Warwick, which was actually funded by the Jaguar Land Rover and the EPSRC. This is our smell and taste kind of device that we actually created this for the British Science Festival. So we're actually giving artificial rooibos tea from South Africa to people from lab-made ones, and it can create it on-site. So human flavors actually combine of 10 different kind of main tastes, and you can actually combine that and just creating like an artificial kind of experience of tea. And finally, we had the device which collecting human body sweat to just understand actually how much sugar is in your blood without putting a needle in your body. Thank you very much. If you scan that code, the QR code, we have a YouTube channel. Most of the non-commercially sensitive things are in that YouTube channel, so you can actually see things. Thank you. See you.
Great. This is the last presentation. I tried to put in as many videos as I could because I knew it was going to be the afternoon. So my name is Cyril Deals. I'm the Deputy Director for the Intelligent Mobility Design Centre at the Royal College of Art. And we conduct design research at the intersection of people, mobility, and technology. And so we're trying to create a holistic perspective on mobility. And so we're organized into 3 different studios. So our People and Place studio is looking at mobility in context. So we're working, for example, with cities to create new mobility systems that are not depending on car ownership, for example. So there's a lot of work around co-designing with citizens and other stakeholders. And we just started to use XR in terms of visualizing future scenarios to help people to imagine possible futures. So that's really early work that we're working on. Then the automotive transitions is quite traditional vehicle design, but we're very much focusing on circularity, sustainability, but also what the impact is of automation and shared mobility in terms of what we expect from future vehicles. And then the humanized technology is, as you would expect, it's about inclusive, intuitive experiences with mobility. So those are sort of 3 complementary studios looking at mobility. So as you might expect, we're using obviously XR for virtual prototyping. So here you can see an example of a small footprint, inclusive, autonomous vehicle. And of course, one of the challenges that people think about is how to interact with these vehicles. So should these vehicles have interfaces? Should they communicate with us? But also, particularly for people with disabilities, can we use AR wearable technologies to enhance that interaction with vehicles and make it more safe and intuitive? Another example here, we worked together with Tata Motors, and we were trying to design an inclusive shared autonomous vehicle. And so we work with elderly people, women, wheelchair users, visually impaired people, neurodiverse people. And I can tell you that it's very hard to come up with a single solution that works for everyone. But we try to at least map as many of those as we can. And one of the things that we try to do, what you can see in the top right, you can see a short animation of, I just stopped now, of something called Gravity Sketch, which is something that was developed at the RCA, and it allows you to model in 3D in real time. And we try to use this technology to actually work with people, so from an inclusive design perspective. But at the moment, our experience is that the technology is still quite clunky to actually use it with non-specialists and a wide variety of people. So there's still work to be done. Let me just see. I see a slightly different image on the screen to the... Shall I press it again? Oh, yes, here we go. Yeah, so the next few examples are really about in-vehicle applications of XR. So if we think about the reality, virtuality spectrum, that also relates to sort of in-vehicle AR head-up displays all the way to really fully immersive virtual reality systems. And I'm just going to show you a few examples how some of the work that we've been doing in this space. So this was some work that we did together with Bentley Motors and Volkswagen, and it was really to allow people in the rear seat to comfortably read or write or engage in other sort of activities. And as you probably have experienced yourself, very often if you try to read inside a vehicle, you get motion sickness very quickly, something that we all know from an XR perspective. And so what we tried to do here is actually provide additional motion information inside the vehicle using these strips that you can see are the lighting strips. And it really had a big impact on people's perception of, and also the level of motion sickness inside the vehicle. So we provided, the blue one was congruent motion in terms of the speed as the vehicle was driving. But we also used anticipation. So for example, a green cue would indicate that the vehicle is about to speed up. A red signal would indicate that the vehicle is about to brake. And it was really effective in reducing motion sickness, but also the overall experience. And I'm sure lots of you are familiar with this, but this is all based around how well the different sensors are integrated. So any discrepancies or incongruencies between the different sensors really have an impact on our perception of motion and also motion sickness symptoms. So related to that, we also done some work with Valeo. Valeo is one of the suppliers to the car industry. And I think it's going to show you a little bit of a video now of one of their games that they've been working on, an AR in-vehicle game. So, as you can see, maybe what we did here actually was to use the forward camera of the vehicle to actually feed directly into the display at the back. And what you expect to see is that there's a big impact on the actual perception of motion sickness. So you can see that making sure that you make congruent motion inside the vehicle really has a big impact in the user experience. And finally, we are currently working also with TU Delft and Holoride into trying to understand how we can engage some of these same principles about motion perception into immersive VR applications inside vehicles. So in particular, we're looking into how can we include anticipation motion cues that provide you information about what the upcoming motion is and how we best design this. And what's really important, and one of the things that I've found throughout the various projects, is that we often tend to focus on technology, and we sort of forget about the actual experience of people inside. So that's sort of my final slide, is to make sure that we don't forget this experiential side of things. So that's it from my side. Thank you.
Now we're going to have a 5-minute break, so you can get some water, and then we'll be back for a panel discussion, which will last until 5:30. Hope everybody will come back from their water, toilet, coffee, smoke break. I will divide the participants in 2 groups. As you can see, we have quite a big group today. So we'll have 2 groups of speakers who will be discussing. I will be moderating the discussion so that we can see, we can actually fulfill the goal of our title, where Morocco and the UK meet with Wallonia, or the other way around. So we can exchange on our ideas and learn more about each other, and also learn from each other. Thank you very much.